Hi everyone, in this video we're going to look at another way to make interesting lattice structures like the one on my screen using the Carbon3D online platform. In my last video I used a plugin called Lattice to make interesting lattice structures, and this is a new discovery, Carbon3D. And it's an online platform. They work with, this company has a design engine for latticing, and they also make products for many different companies, including Adidas. I first discovered them when I actually found a pair of these shoes. I thought they were pretty cool, and started looking into the manufacturing process, and that led me to Carbon, which has a number of different interesting lattice patterns that can be used with mesh models. So unfortunately the platform is not free. However, at the time of making this video, they do have a free trial, and you can use the platform for a few weeks. Carbon3D.com, the design platform is called Design Engine, and you get to it by going to Platform, and let's see, Design Engine. And here's where you can make a free account. And I'm going to pause the video and log in and show you how to use Carbon. Okay, so I've logged into the Design Engine Pro, and we want to get started here by clicking on Create New Design. And you'll see that I need to upload a file, and the file that I need to upload is an STL. And so I'm going to go ahead and jump over into Maya, and this is an interesting mesh that I made using the Bifrost plugin. And I have some other videos on the channel that go over how to make things like this. And I want to just take you through the process of exporting from Maya, going over to Rhino to scale things correctly, and then jumping into Carbon. So just to sort of review here, the default units for Maya, if I can find the settings here, is centimeter. And Carbon, if we look here, is going to need a model unit of millimeter. You can either export or import in millimeters and inches. And so I could scale this up by 10, either here, or some of you may be coming from Rhino. So I'm just going to go ahead and show you the whole process. So I'm just going to go ahead and export this selection. And I am going to use the OBJ file. Let's throw it on my desktop. So test OBJ, export selection. And then let's open Rhino. Let's see here, file, new. No. And I'm going to open small objects, centimeters. So I'm in the same units as Maya. And let me go back to the shaded view and go back to the perspective view here, sorry. And file, import, let me import that. Test OBJ, okay, sorry, it's here, open. And I want to map the OBGY to Rhino Z, pull that in, zoom selected, and now I have this interesting mesh. And I'm going to go into the shaded view. Okay, cool. So I have this thing. Let's look at this bounding box, see the basic distance here. Okay, great. 10.765 centimeters. Okay, so now I'm going to type units. I'm going to convert this to millimeters. So millimeters. Okay. And then it's going to prompt me, do I want to scale the model by 10? And I want to hit yes. All right, so now I have this bounding box. Let's just double check the size of it, distance. All right, and this is 107 millimeters. Okay, great. So this is what I'm going to take into Carbon. At this point, I'm going to save this, export the selected as an STL file. So let's change this to down here, STL. I'm going to put it on my desktop, test 2, test for Carbon. How about that? STL, hit save, and the options here, I'm just going to keep the default. I haven't tested open objects. This is a closed mesh, so I'm not sure if it would work or not, but this guy is a closed mesh, so that should work fine. All right, so let's close these, coming back to Carbon, and let's see. So I need a part, name it, let's call it video test material. I'm just going to select other because we don't have a particular application in mind here. Let me pull up my, let's see, desktop here. Sorry, I'm going to pause the video real quick. All right, I found my desktop. Test for Carbon was the STL test for Carbon. I can drag that here, and then I just need to hit create. Okay, great. Okay, cool. So now we have this mesh, and oops, that's not so easy. The navigation is not quite what I'm used to. So left, right mouse button to kind of pan around, and middle mouse button pans, right mouse button helps me rotate around. Okay, so to create a mesh here, I have my object. I can now, there are a couple of options here. We're going to keep this simple and start with a strut lattice. And our object is about 107 units tall. There is a way, or millimeters tall, there is a way to kind of measure here, and you can get some sense of what these, so I can see here Z 104. So this helps me kind of be reminded of what this is. There are a lot of different mesh types here that were, lattice types that you can use. I'm just going to keep it simple with the tetrahedral mesh. And I'm going to accept the default size of 5 millimeters, and I'm going to hit generate. And one of the really cool things about the Carbon lattice is that it will actually read the surface. So the last latticing tool that I showed on my channel was intralattice. And intralattice is great, but it doesn't actually read the surface of the mesh. And so I think that that's the main advantage of this tool. It will actually put struts along the boundary surface of the mesh, which is also one of the reasons why it takes a little bit longer. I'm going to go ahead and pause this while it's processing. It shouldn't take too long, and we'll look at the results. Okay, so I'm back. Here's the result. This took about, 5 minutes to crunch. It's a pretty dense lattice, and I'll show you in a moment how you can turn off the boundary. After touting how cool it is that you can get these boundary surfaces or struts along the boundary, it should run faster if you turn off that feature, and you can also get really interesting results with that feature turned off. So I'm going to go ahead and let's see, turn off the base surface, and then now you can see this in this incredibly dense lattice here following the shape. And again, I think that the really powerful feature of this, which not all latticing tools have, is the ability to read the surface with the lattice itself. So I'm going to go ahead and turn this off. Now, if you want to then download this back into to Rhino, you need to, this is just, let's say, the how it's going to apply the lattice, and now we need to use a solidify tool here, and hit generate on that, and this will actually create the mesh. So I'm not sure how long this is going to take, so I'll just quickly pause the video, and hopefully this won't take real long. All right, so that took about a minute to create, And so I'm going to turn off the strut lattice here, and that's the lattice generation, and this is the final mesh. Now you can see with Solidify you can you're basically getting a series of mesh tubes, and you can set the resolution of those tubes. So by default you get a 6-sided profile. You could make this lower resolution, you could go down to 3, make it a higher resolution. This is going to be fine for what we're going to show, and then if we want to bring this back into Rhino, we just need to come over to the Solidify mesh here and hit download. And over here, I'm just kind of download this to my desktop. So video test Solidify STL, that's fine. And it might take a minute to download. Where are the downloads? Okay, it's coming down here. And then let me just get Rhino ready. So we'll bring this back into Rhino. File, open. Oops, no, when I import that, just find here my downloads, show in folder, video test Solidify, STL, and let me just bring Rhino up and plop this in, and we can see what we have. And I just want to import this. And millimeters. Taking a minute, there are a lot of parts. Let me pause it while it loads. Okay, so we're back, and the mesh has loaded. It's an incredibly dense mesh, and it took several minutes to load, which is pretty atypical for Rhino. So I'm going to go down to wireframe. It's impossible to see anything. So let me go to, I don't know, let's try the Arctic view. Okay, so cool. This, now we can see the mesh. So you can see it's incredibly dense. And let me see if I can select the base surface and hide that. Right, and so now we can see the final mesh result. So it's very cool, incredibly dense and slow. Maybe if probably each individual element is its own thing. And I'm guessing that if I selected everything and then joined it into one mesh, Rhino would process it a bit more quickly. But I actually want to go ahead and just, I don't know, let's turn this off. Maybe select all. Throw this on a layer, and I want to show you how to make a less dense mesh using Carbon. So let's kind of change object layer and turn this off, and let's make a less dense one. Okay, so coming back to Carbon, oops, I'm sorry, I was looking at the design blog while all this stuff worked. Okay. So you can see here that we have our Solidify, we have our strut lattice. We could regenerate everything. I'm just going to go ahead and delete this and go back to the strut lattice, turn this on here. So let's look at the settings here. All right, okay, so the settings were 5 millimeters. And what I found is we could bring this up to say like 10 or 15, but the thing that I keep touting, the ability of Carbon to read the surface of the mesh works better, I found, at a smaller scale. And it takes longer for the lattice to generate. When you start making this cell size larger, if you keep on that feature. So we're going to turn off that part of it. So here we have the unit cell, we have zones, and now we have advanced, and we can look at the boundary struts. So apply feature edges. This is the tool that is forcing the reading of the surface on the boundary, and we can turn that off, and that should make the calculation of it faster, especially once we start making this bigger. So let's go ahead and move this up, I don't know, from 5 millimeters to a much lower resolution, like 20. It's also giving us a warning that the diameter of the strut needs to be raised. So the strut diameter should be 10% to 30% of the cell size. So 10% of 20 millimeters would be 2 millimeters. So we're going to bring that up. And now we're going to hit generate. And let's see what we get. I'm guessing this won't take so long, but I'm going to pause the video. Okay, so this took a couple of minutes to generate, and you can see that the shape itself is fairly complicated, and we've now gone up to a very large cell size. And so what we get is a much more sparse mesh, and because we've turned off the reading of the perimeter, it was much faster. And also, I don't know, I find the form pretty interesting. And so at this point we might, so if we wanted to bring this into Rhino, we would again just hit the solidify tool here, and we would then be able to download that mesh. I want to go ahead and play with some of the other options here, but before we conclude this video. So let's look at some of the other options here. So let's look at maybe the Kagome mesh here and hit generate. So this one is giving me a slightly more dense mesh. Pretty interesting. And maybe I'll just go ahead and I don't know, because it's more dense, I'm just going to bring this one in. There are lots of cool things that you could do with Carbon. You can actually, if I go back to this here, you can see that it's possible within a single model to have multiple lattice types. And it's out of the scope of this video, but what we could get that by putting another volume in here. You could actually add a shape like a cube or a cylinder, and then use that as a mask to transition from one lattice type to another. And so this is where we could add zones, for example, to, as it describes here, alter the lattice parameters for the given subsection of the boundary mesh. So I think that the way this would work, I haven't tested this, is you could add a shape here, maybe in the middle or at the bottom, and then you could transition from one lattice type to another. Maybe we'll do a future video on that, but it's out of the scope of this video. All right, so let's just go ahead and conclude the video by bringing this one back into Rhino. So I'm going to hit solidify. And let me pause the video while this sorts itself out. Yeah, there was a little error, and I think it was because I had the strut lattice selected while I brought the solidify component into the stack here. Okay, so now we have our solidified mesh, and let's go ahead and bring this in. So I'll download that. We will call this solidify Kagome. And then let's find that, downloads, jump folder, bring up Rhino, bring up my folder, and I'll pull that over. And I think that this shouldn't, oops, sorry, things are popping up on the other screen. Import, I'm thinking that this, since this is a much, oh, one more thing here, millimeters, okay. There we go. So this one just popped right in. And I think it's honestly a more interesting thing. It's also interesting to combine these guys. You can overlay the different meshes that you've made with Carbon. Oops, I want to do that. Turn that one on. But this is a pretty interesting structure. I like the way that some of these struts begin to curve and bend around. It's a little bit of a macaroni hairball, but we could then, of course, come in and sort of prune this if we wanted, and to sort of delete parts or extract parts to make this. To give it more of a silhouette or figure. There are all sorts of things that you could do with this. You could thin it out, but pretty interesting structure. And so I encourage you to play around with the Carbon design engine. It seems like a fascinating tool.